Good day everyone, this is Vlad Kustov again with new video about covariant tensor machine. Today I tell you about how the CTM works in differential geometry. We will know what the nature of parameterization is. The goal consists of a calculation length of circle. I will show you one of representation of time because in this case its natural parameter. Initial data is a circle that has a radius and angle length is equal 19 degrees. Necessary calculation length of circle in linear units. From definition of CTM, I remember that angle of curve can't have angle length is equal or more 90 degrees. From past video, I remember that the CTM works with vector arrows and angles. In addition, machine receives symmetry. From differential geometry, I knew that any curve has characteristic. There are tangent vector, normal vector, and angle length. In addition, I knew that CTM is the scalar connection between vectors. In that way, necessary it finds out the length of tangent vector. Geometry tells us that curve has either of a possible parameterization. In this case, it's a concrete length of curve. Circle is a curve that has a constant curvature and other symmetry features. If a point moves on trajectory with constant velocity, that in the middle moment of time it has gone half of way. In this case, it half of angle, so as to find out an angle bisector. It's a simple necessary. It builds a chord. Chord has a middle of length. It's a second point of a straight line for the angle bisector. Cross point D uh, between line of the angle bisector and circle is a middle of length the circle line. This point D is a point for derivative. Tangent line has cross point E with tangent line from initial point A. Therefore, E is a middle point of three coordinate x, y, and angle. I mark one thing. That curve has parameterization and the CTM receive tag of it. Therefore, E is a point of connection with end of curve. A term of the CTM is a vector of natural parameterization EB vector. Since it has symmetry and constant parameter, it's not difficult to understand that line connection B point and TXA is a circle. Another word, it's a rotation of EB vector. Cross point F is end of velocity vector of circle curve. Length of invariant of AF vector is the length of circle. Let's check up it. I draw this diagram on projection program and measuring or a length of circle and vector line. Calculation tells us that is the same with small deviation. It's 0.1500 of percent of quantity units of length. It connects with constant pi or pi function. Today I told you about nature of parameterization. In future it will become a proper time function. Thank you for your attention. Remember that gravity is a cradle of humanity.